Hello, my name is Louis Carr. I'm the Senior Director for Product Marketing and Management for Data Management at Actian Corporation. And today I would like to talk to you about the future of edge data management. Specifically, we'll talk about why the edge intelligence we're going to see going forward is important. We'll talk about the key considerations for managing data in edge applications. And we'll also talk about some of the use cases that we have in working with customers here at Actian. However, before we begin with our look at edge data management, I'd like to give you a little bit of background on Actian. Our mission is to deliver data management integration and analytic solutions, all focused on hybrid data. That is the combination of data at the edge, in the data center, and of course the cloud, of all types of data, whether it be your traditional structured data, semi-structured data, or completely unstructured data. We've developed an understanding of data over a period of 30 years. And at this point, we have revenue annually of over $100 million. We have over 10,000 customers, and we are owned partially by a large systems integrator called HCL and also by a private equity firm, Sumeru. However, we are independently operated by a board of directors and our CEO, Rohit D'Souza. We have over 300 employees across 15 countries, and we offer 7 by 24 multinational support. Again, our focus is on innovation, and today we're going to talk about that innovation specifically with respect to edge intelligence. And the fact of the matter is that use cases for edge intelligence are everywhere. They can be summed up as a culmination of inexpensive yet extremely powerful compute resources being placed in devices and machinery that was once siloed and limited in functionality. These compute resources are then used to integrate, automate the use of the devices and machinery specific to the business operations in every industry, from MRI machines in your local hospital to sensor grids at the chemical processing plant or oil refinery you might pass on your way to work. These business operations are then more intelligent, more agile, and better instrumented such that their operators and the back-end line of business management responsible for the bottom line are able to see how efficient they are, what can be improved, what the satisfaction rates and usage behavior is of the end users, and generally you'll be able to transform those operations at the point of action such that you're able to deliver better outcomes, reduce costs, and in effect, take that edge intelligence and turn it into superior outcomes. But to really understand how edge intelligence will be used and how effective it will be, you really have to focus on the data distribution, sharing, and local persistence. And to do that, you have to understand that the edge is not a monolithic single platform. It is split up into an edge of the cloud, on-premise, a series of gateways, much more complex, sophisticated devices that are either directly connected to the cloud on-premise or those gateways, and then less sophisticated devices below that, out into grids. And it's much more about processing of the data on the devices by the local software. It's much more than that. It's really about the fact that that software, particularly the data processing and advanced analytics components of the software, require contextual data that is from off-device sources. So the algorithms used are more than likely developed, tested, and tuned in the cloud or the data center. And the metadata used to support management and monitoring of these devices and the networking of them with other devices is also something that requires the data to be processed and analyzed not just on that device, but shared across that entire network of edge devices. So a critical facilitator and driver of sharing across these devices and network is the high bandwidth networks that are required. And you'll see increasingly that these networks are much more than just, what you are hearing about, which is critical, that is 5G. But, downstream, lesser bandwidth, but still extremely impactful, low power wireless technologies for IoT, such as Cat-M and NB IoT, as well as fixed point wireless above the 5G that might be in remote and branch environments is also a critical component. So it's really the need to understand how to manage data across this entire environment, this entire ecosystem that's critical. But before we get into dealing with exactly what are the requirements and characteristics of that edge data management across that environment, let's first level set with the fact that all of that data is managed, manipulated, applied through software, through application software. And so at the end of the day, all these improvements um, uh, really wouldn't make any difference. That is, all of this new compute intelligence out there without the ability to code. And in turn, that wouldn't be possible without the software developer. So when you hear buzzwords like digital transformation or getting more value out of IoT, what you really need to think about is the software developers, right? These folks are the ones that are dealing with this rapidly increasing number of apps and the speed of the updates of the apps. They're the ones that have to deal with the size of their teams. While they may be growing incrementally, they are certainly not keeping up with the exponential pace of the growth of the actual workloads that they're dealing with. And the result is that we see a shortage of developers in key areas, particularly mobile and on IoT or mid-stack app development, right? And these are the areas that are going to be most crucial for dealing with the edge intelligence, and edge data management is a critical part of that. So the tools, methodologies, and culture are really the important thing that's going to be necessary. So that's the core piece. That core piece in terms of dealing with the software development has to be then put into perspective because with that shortage of developers and with so many different projects you can do or could do, you have to prioritize exactly what you're going to do in with the resources that you have. Where should you innovate? And that's going to be a business decision, right? So if it's a business decision, you're going to have your developers having to work in the right cross-functional teams, partnering to prioritize and focus their talents on the business challenges and goals that you have. So first and foremost, those line of business managers have to be looking at what are the aspects of the edge that are being added to their products and services. How does the data management play into the value, the features, the functionality, the usage of those products and services, particularly around the edge? And some of that's going to mean that they have to look at things like process reorchestration. They're going to have to look at how their products play together, particularly if it's a product line. Let's say you're in the agribusiness and you've got everything, all sorts of farm equipment, or if you're a medical equipment instrumentation company, then you've got several different instruments that might be in an operating environment for operating rooms or something. So it's important to understand how these things fit together and how you may also have new business models because of all the data that you can extract or send down to that edge. And finally, then you have to look at how is this increasing or reducing your risk, right? Because as you add in more and more software, you add in more vulnerabilities from a security standpoint, you add more complexity from a service and support standpoint. So then the question really becomes, with all of this embedded analytics and data management at the edge, what's it going to mean for your actual applications? With the right teams in place and a focus on end user centricity, you should be able to look at the instrumentation of each of these components within that network and across multiple components in a way that you're providing better end user response, better end user usability, and so if that's the case, then you should be able to provide better seamless contextual multi-channel support. That is, I am able to look at an application from a different device and still see that same set of data. I'm not having to re-enter the data. If I've got a machine that is running and leveraging data from other machines, it is helping it to better understand the quality of service that machine in and of itself is delivering. I'm also, as I look at the actual process, I can determine if that process is having exceptions because I didn't fully understand where there are going to be requirements for particular answers or an understanding of a particular environmental event. And so over time, what you hope to do with things like machine learning is to adjust and ensure that you can solve or predict ahead and satisfy for that event so that you, going forward, will no longer have that particular exception. And if you're able to have this across your multiple channels and increasingly over time provide better and better usability and functionality or effectiveness of that functionality, you should be able to get stickier human engagement over time. And that's the whole point of having something being analytics driven. And then over time, that automation moves from just decision support for human beings to better um, decision direction between the machines themselves. Ultimately, whether it be human to machine or machine to machine, this will eventually lead to more value and profit from your products and services. But the question still remains, are you ready to harness that edge intelligence? And our feeling is, and our understanding based on dealing with our customers, is that that's only true if you've got the right data management solution. And actually, we believe that there's really 8 key requirements for modern edge data management. And the first is that you need to be capable of handling large sets of persistent data. And there's always going to be a need for distributed data, right? The data is always going to, some fraction of it will always be sent up to the cloud. But increasingly, the requirement is also that there is a baseline set of data that has to be local on the device. And one of the reasons for that is that increasingly devices are interacting with people using language, specifically the language that's locally selected by that end user, whether it be English, Chinese, Spanish, what doesn't matter which language. That means that you really need to have local dictionaries, for example, and the conversation means that there is a continual look up, a search for the right words and the right grammar and syntax and translation. It's just one example where um, if you really have, it doesn't matter if you go to 5G, if you have so much more in the way of verbal and audio communication between humans and machines, the latency will kill you even if you go to 5G. It's just one example. Others could be virtual assistants that aren't just doing audio language translation, but for the specific type of business process, specific to that industry, to that particular context of the process being delivered, you're going to have automated virtual assistants that do decision support. And these are just a couple of the myriad of examples of why you're going to need local persistence for the data. Another is simply as you have streams, multiple streams of data flowing into a device, let's say it's managing a grid, then I need to be able to do something like signal to noise ratio efforts to make sure I throw away spurious data, that I am able to pre-process so I'm not sending so much data up to the cloud, even if I were still planning to send all of it up there. Another issue with the edge, as you see in number two, is that there's not a ubiquitous single homogeneous environment. It's not the age of Windows like it was on a PC, or everything's moved into being open source Linux and just a few variants of that in the data center. You have all sorts of different operating environments. You have different developer tools. The tools are being used with different languages, right? Which is what we're saying with number three. So you've got to be able to handle all of these different environments, different operating environments on different processors, on different hardware variations. There's also, as you see in number four, variation to the type of data. You'll see JSON data, semi-structured data. You need to be able to parse that data. Other times you could have video streams of data as just large binary objects. And then, of course, you're still going to have your traditional structured data, and you've got to be able to handle all these different data types. You've got to be able to handle these streams of data in ways that mean you are time slicing and handling multiple streams of data coming into a single location. In that sort of environment, really what you have is the equivalent of client server. You can call it subscription and publication of data, but the point is that there's going to be this need to handle all of the downstream data locally. You can't simply have one server up in the cloud and then have all of those clients going directly to it. That sort of topology is not going to work. The other issue is that if you're looking across a process and that process has a state to it, then there is going to be synchronicity to how that data has to be placed from device to device, at what point in time, how much of it, what is the response, how is the event triggered, and so you're going to have things in a way that's not always stateless sharing of that data. You also have to solve for the fact that you could have periods of disconnectivity. Even with high bandwidth, you're still going to have points where you drop out. And so again, the local persistence of data, reconnecting, determining where you were is going to be critical. And of course, all of this is going to happen at increasingly higher speeds across multiple channels. The other point is that you're oftentimes going to want to be able to either locally, remotely, out at an oil rig or in a hospital or wherever it may be out in the field, be able to analyze both raw, pre-processed, and fully processed data out at that edge. And you don't want to be reinventing the wheel for specific pieces of reporting and visualization. So you want to be plug and play for all of the tools and support. And so to sum it up, these are the key requirements of an edge, modern edge data management solution. And so if you look at those requirements, the first thing you have to do, whether you're one of the developers is selecting a way to do data management in your application, or you're a product manager or a line of business manager working on determining exactly how your product is going to leverage data to become more intelligent, to deliver better services. You're going to have to understand where you are in what we call an edge data management maturity curve. Now, the fact of the matter is that, a lot of the time we have to look at, where we are, where we've been to determine where we are and where we need to go. So when you look at edge data management, really, there's two sides of a coin that you could look at. On one side, the edge, the data management that you have to leverage is what comes out of the data center, right? The data center data management solutions have been around for quite a long time. The fact of the matter is, though, they don't necessarily fit into the embedded space.